Hello, everyone. Welcome. My name is Daniel Moyer. I'm a sales support trainer here at Simplify Power Briggs & Stratton. Also with me is Nathan Heston. Good morning, Nathan.
Good morning, Daniel, and good morning, everyone. Happy to have you with us today.
Yep. Today, what we got for you is charge, discharge, and state of charge. We're going to talk a little bit about how we charge batteries, how we discharge them, and how we measure the state of charge. How do we know how much fuel is left in the fuel tank? We're going to talk a little bit about some of our products, and then we'll kind of wrap it up with looking at some of the kind of system diagrams and pictures. A lot of good install pictures. Everybody loves to look at a picture and take a look at the story. This is a NABCEP accredited course. So if you're here for your NABCEP continuing education credits, at the end of this presentation, my email is going to pop up. You're going to go ahead and email us your full name so we get it spelled correctly on your certificate. And then we'll check the attendance records and go ahead and issue those credits accordingly. Again, another housekeeping item is that if there is any questions during the program here this morning, put them into the Q&A chat feature. It's usually a button either at the top or the bottom of your screen. And we'll go ahead and address the questions either during the presentation or we'll carve out some time at the end as well. Let's get started. I'm really excited to be here. One of the new kind of great news items we have is that we've extended our warranty. We now have a 15-year warranty on our batteries. And we're going to talk a little bit about what that means. Really what it means is that there's no cycle limits. There's no megawatt hour throughput limits or energy throughput limits on the warranty. And there's no specific depth of discharge we're calling out on any of the warranties. So really excited to share the battery warranty. We still have a 10-year warranty on the inverter, but the batteries, really, a lot of people think of the inverter as the that's what they interact with. That's what a lot of the functionality is about. And it's true, right? The inverter does a lot of functions, but what's holding that power? How do we charge it, discharge it, and how's that state of charge? It's these batteries that really are the workhorse of a lot of any energy storage system. So this is one of those great marketing photos that doesn't necessarily replicate what it's really going to look like on your customers' homes. But what you can see there in the picture is one of our inverters and 3 of our Simplify 4.98 inverters.
So Daniel, it's a great point on our communicating batteries, having this 15-year warranty with unlimited number of cycles and unlimited throughput. Daniel's going to talk about it a bit later, but one of the things he was mentioning there is that photo didn't really represent an accurate portrayal of what this ESS system looks like. That's a waterproof battery, and there's a conduit cover that goes over the box, etc. And he'll be showing that to you a little bit later as we move through the presentation.
Yeah, it's always great what the marketing people can come up with. So one of the really exciting things is Briggs & Stratton Energy Solutions is really one of I think only 2 people in the country that produce both energy storage systems, right? ESS systems, home batteries, and generators. So we're uniquely positioned to be the provider to you and the installer of both energy storage systems and generators, right? What does that mean? It's one tech support call, it's one price list, it's one warranty. So it's really exciting to be to combine the Briggs & Stratton brand with our Simplify proven battery technology into one complete integrated energy solution provider. We assemble the batteries here in Oxnard, California. So we have an excellent track record of quality control, not only with the battery cells, but also the battery management systems, right? The little computers inside each of the individual batteries, as well as the inverter. The generators, engines are manufactured here in the United States. So it's really exciting to see that we're able to keep this stuff in the country and provide them together, have a solution you can count on.
So Daniel, great point on the BMSs. I'm sorry to interrupt here, but I do want to mention to everybody, we do have a training coming up on BMS. So if you're interested in that functionality, as Daniel mentioned, we've really got a Cadillac of a BMS designed here in California It's really overbuilt and offers some unique functionality through our software. So if you're interested in learning more about the BMS, look for that upcoming training on our training calendar.
Yeah, thank you, Nathan. That's a great point. We spend the whole hour just talking about battery management systems. What do they do? Cell balancing, and they can also communicate the state of charge, which we'll get into a little bit in this training as well. Thank you, Nathan, for that. What's driving these systems, right? Why are people adopting energy storage systems? Is really kind of came out of the pandemic. A lot of people are using their home as a haven. A lot of people are working from home. We got a lot of retirees coming in. So what we're looking for is reliable backup power for your home, not just for your lights, but also to keep the communication lines open and keep that router powered to maintain the connectivity. A lot of times in large outages in the communities, cell phone towers go down or become overtaxed. Whereas if you can keep your internet up online, you're able to maintain those communications. Existing infrastructure really hasn't been invested in as we'd like to see with our grid. So it's aging out, and there's a lot of opportunities for these energy storage systems to really help maintain grid stability. When we're going to talk a little bit about it here in is time of use arbitrage, but also being able to participate in demand response programs where you let a utility or a utility integrator essentially kind of take control of your energy storage system and allow that energy storage system to be discharged when somebody else decides. Why would you want to do that? Well, one, you're being part of the solution, not part of the problem, and you also get financially compensated for that, not only for being part of those programs usually, but also for every amount of energy you send back out onto the grid. Climate-related disasters, right now everybody is probably thinking about the heat wave, but I know hurricane season's coming up, and winter is just around the corner with ice storms and high wind events. So keeping the lights on when these major weather events happen is really crucial. Electrification of everything. We're seeing that here in California. In fact, a lot of new homes in California don't have new gas lines. There's no natural gas lines going to these new homes. So what does that mean? It means heat pumps. It means heat pump dryers, heat pump water heaters, electrification of everything, and especially with also the adoption of electric vehicles. So having robust distributed assets like energy storage systems on your company's homes are really going to help create that future electrical grid. There's a lot of money available to make this a possibility with the new IRA. They extended the 30% tax credit into the 2030s. And it's important to know for everybody, it's a tax credit, not a tax deduction. So if you're like me and I do my company takes my taxes out of my paycheck every month or every 2 weeks or whatever, and at the end of the year, I usually end up owing the government, the feds, nothing, and they owe me nothing. Had I installed an energy storage system, I would receive a 30% tax credit, right? A rebate check for whatever that amount was. Say it's $10,000, I'd get a $3,000 rebate. So it's a credit, not a deduction. Additionally, with the new IRA, you can now install energy storage systems alone without having to couple it with solar and still leverage that 30% tax credit. So a lot of market drivers that are creating this kind of this headwind, really, or tailwind, right? The headwind's the opposite. This tailwind for our industry. We talked a little bit about some of the drivers. What are some of the applications? Upgrading existing solar homes. A lot of people have solar out there already that didn't have a battery system installed initially. Now's the time to either AC couple, or maybe if you have an aging out grid-tied inverter, maybe that old SMA or an old Fronius inverter that's about to expire the warranty, maybe consider just ripping it out. And let's go ahead and DC couple in a solar array into our inverter, to our Simplify inverter. That way you're not getting that losses from that additional conversion from AC to DC, or DC to AC, I should say. And really you're not kind of putting in a weak link in the system that could fail. Time of use arbitrage is really important. Those new solar and storage incentives. Being a solar ready home, we're starting to see those in California as well, where you have a home that essentially has maybe conduit already pre-installed up to the attic. Maybe it has a specific location on the roof that's south-facing. Maybe it has a meter main or a main electrical panel that has an upgraded bus bar, a 225 bus that's able to take more backfed solar. Off-grid is another one. That's always been the historic start of this kind of solar revolution is the off-grid industry. And we do have our inverter is warranted for off-grid use, which is unique in the industry. Backup power, replacing existing energy storage systems, like I meant, it's kind of not quite there yet, but I think it's coming. Peak demand rates and that demand responses as well. So now's the time really to act. A lot of people out there have solar. A lot of people who have solar may not even realize that their solar doesn't function in a grid down situation, right? We have to have a grid forming inverter to create a microgrid inside the home, disconnect us from the utility grid, and trick that existing microinverters, trick that existing string inverter to stay online. And if it's something that you guys are interested in, make sure you reach out to our design team to let us know what existing infrastructure you have, so that we know sometimes those older inverters don't necessarily AC couple well with anybody else's grid forming inverters. So now's the time to move. We really expect this to move forward. And I'm really excited to see, 10 years from down the road when you and I and this whole industry have really started to move forward. The advantages of solar, we kind of already touched on this. You get backup power. What is it worth it to your homeowners, to your business owners, that they can keep the doors open, they can keep their food cold in the refrigerator, and they can keep their lights on? You really can't quantify that as a price, right? It's something that's almost a necessity. Maybe you keep a mini split air conditioner on, so you're able to keep yourself cool and have a refuge room in your home. Saving money is definitely going to be a part of it. I know here in California with our new net metering agreements, you're no longer having this favorable 1-for-1 credit, where if I have my solar is producing during the day and I'm off at work, the kids are in school, and I'm backfeeding the grid and I'm earning credits on my utility, and then I can utilize those credits, kind of a 1-for-1 credit at night or in the winter, for example. That's gone away. With the new net metering 3.0 or NEM 3.0, you're no longer getting that 1-for-1 credit. So what that means essentially is that if you produce energy during the day with your solar and you don't use it and you don't store it, you essentially lose it. So the idea that you can capture that clean energy during the day and then leverage it at night is the only way really to make grid-tied solar financially viable in California. And I expect to see that in other markets. Hawaii has already been there. Hawaii's been doing that for a long time. Essentially, you're not allowed to backfeed the grid at all. Off-grid, again, we paired that already. We talked a little bit about that, but being able to live off-grid and have a system that's warranted is really crucial. We also, and we'll talk about this here in a second, offer energy generators. And when we do have a generator line of what are called non-emergency generators. A lot of generators on the market are standby generators, where they're really only warranted for situations that are going to be in standby situations, right? You got the grid goes down, you can start the generator. Our non-emergency line of generators are warranted for off-grid use, more of that continual use. And we do also have another training coming up next week where we're going to talk a little bit more about how generators and energy storage systems can complement each other rather than compete with each other. One of the things that we've always been known for here is having a very safe battery. And what makes our battery safe is really the chemistry. And using lithium iron phosphate chemistry is what makes our battery less likely to go into an unmitigated thermal runaway with propagation. So we don't go too deep in this. We, again, have other trainings where we talk more about this, where we take our batteries, we send them off to the UL labs, and under these 9540 and 9540A large-scale fire test protocols, we essentially force our batteries into thermal runaway and watch what happens. And kind of a spoiler, not much happens. So we're really excited. We make these 9540A test reports publicly available on our website, and we're really excited about it. And as I just mentioned earlier, what's the market going to look like from 5 or 10 or 20 years from down the road, where in my neighborhood, there may be a battery install here or there, or just a couple in the neighborhood. But what is it going to look like after we've been hard at work and we have batteries in every other home in the neighborhood? What is it going to mean for the stakeholders, for firefighters who might have to respond to these events, for homeowners, for manufacturers, and you as the installer? You don't want to be known for the installer that put in a system in the neighborhood that caught fire. So I do see a lot of other manufacturers moving towards lithium iron phosphate, away from a lot of those cobalt-based chemistries. And so I think a lot of people are recognizing the inherent safety and why chemistry matters. Also, form factor matters. And if you were to open up our batteries, essentially you would see a lot of cylindrical cells all packed in series and parallel configurations to create these packs. We just mentioned it. I'm going to talk about it here really quickly, is that 15-year warranty. And one thing that really we can stand behind this 15-year warranty is that we've been making batteries for 15 years, right? We actually have batteries that are outliving some of their warranties. So it's not to say that we just started our company 5 years ago and we're offering a 10-year warranty. No, we've proven, and we actually do have batteries out there chugging along right now that are approaching 15 years. One thing I do want to see is that if you do, think about the warranty, there's no, whatever comes first. A lot of other warranties might say, okay, you get 15 years or 10 years, but if you exceed a number of cycle life, that comes first, and that's your warranty. Or a number throughput is also going to matter. At the end of your warranty, you're going to be guaranteed to have 80% of the capacity of the battery left in the battery available at the end of that warranty period. So Nathan, I love seeing this. One thing we're going to be talking about here in a second is charging our batteries and discharging the batteries and the state of charge. And one thing I'm hoping you could speak to is when we're charging a battery, we don't want to charge it too quickly. We relatively can charge our pretty quickly, but we're going to talk about this as specifically, and probably a lot of people don't have this on their mind, is cold weather charging. So what can happen when we charge a battery too quickly, and what can happen to a battery cell when we charge a battery too quickly when it's cold?
So good question, Daniel. So I've got a little background noise, but hopefully Zoom can filter that out for us. Well, first, I do want to make a quick clarification on the 15-year warranty. That's on our communicating batteries, and it's a slightly lower reduced capacity after 15 years, but we do guarantee at least a 70% remaining capacity after 15 years. We guarantee 80% after 10 years. So you're really getting and this is unlimited number of cycles, as Daniel mentioned. So you're getting a really long life out of these things and very slow degradation. So batteries have gotten better and better, especially ours. We're willing to put company name on the line. And I do also want to mention, with that 15-year warranty, you're being backed by a company that has been around in the United States for 115 years. So it's a real standout warranty, and it's being backed by a company that's not going to disappear in 5 years. On the topic that you mentioned, Daniel, we're not going to have this talk be all about form factor and how batteries are made. We have whole talks on the chemistry and how batteries are made, but know that there are different chemistries, and the chemistry best suited for home battery backup is lithium iron phosphate. As Daniel has mentioned, that's the safest chemistry. That's the one that Simplify has been using for 13 plus years now. We really have a long history with that. And as Daniel said, our batteries are outlasting their original production, warranty from years ago. We use to achieve that durability and that long warranty, we use the longest lasting battery chemistry, that's lithium iron phosphate. Additionally, we use the best type of cells to achieve that longevity as well. There are different types of cells. There's the three particular or most common types of cells are prismatic, pouch, and cylindrical. We build our batteries with cylindrical cells. That's the best cell, the longest lasting cell. It's also the most expensive. So we can't come in at the very lowest price point, but we believe that we meet it on quality. And when you look at throughput for our batteries, you get more throughput. That's the number of kilowatt hours you charge and discharge, basically the amount of energy you store and use. What's happening inside a battery? Well, essentially, when you're charging a battery up, we're moving lithium from a metal oxide where it likes to be over to a graphite side of the battery. Now, inside that battery is a liquid electrolyte, and you have a porous separator layer separating that metal oxide and the graphite. That electrolyte that's inside there can burn, right, in the event of a fire, right? So it's not unique to our cells. All of these lithium cells have that electrolyte inside there. But as Daniel mentioned, lithium iron phosphate burns at a much slower rate. And we basically, even if we intentionally catch our battery cells on fire, they self-extinguish. So we'll keep going. If you're interested more about this chemistry, we have whole trainings on that as well.
Thank you, Nathan. This was a great visual example of what it really looks like between the differences between these chemistries. Will Prowse, who probably a lot of you have heard about, has a great YouTube channel. And what you're seeing here on the left is essentially a cobalt-based battery shooting flames out of it. And on the right, you can see where Will Prowse has had to drill that pouch cell, LFP pouch cell, multiple times. And all you're really seeing is some venting of some gases. This is kind of a little quick overview of the batteries. That's kind of the idea behind the cell packs in there. Each of these individual cells are putting these packs in series and parallel configurations. What you're seeing on the right is one of our communicating batteries. All of our batteries have a built-in breaker, which is great because it provides a little more safety, right? Not only for overcurrent protection device in operation, but also during installation. You can turn a battery off, right? You can't really turn your car battery off, but with that internal breaker, you can switch the battery off, make all of your connections, wire up our batteries in parallel. You never want to wire them in series. Additionally, you can see the COM ports, which are then being able to kind of talk to the battery management system that we have inside that top of that battery. A lot of you kind of already understand the concepts, but what is an energy storage system? Really, what it is kind of the heart of it is this inverter, right? This inverter is able to go into an island mode where we can disconnect ourselves from the grid and then use multiple energy input sources, such as solar or a generator, to charge up batteries. And then we can then utilize that stored energy in the battery to power home's electrical load. We can always make sure we keep an eye on the system using a monitor. We have energy track, and that's what people look at nowadays. It's not like the old off-grid days where somebody might walk out to the power shack and look at the old Xantrax inverter or the old Trace inverter. They want to see an app. Installers want to be able to see an app to do fleet management. Homeowners want to be able to see the map, an app to be able to monitor their battery level. So that energy control system app is actually really crucial, and I think it can be set us apart from some of our competitors. That's what people interact with, and whether the inverter is great, the batteries are great, if they don't like the app, you're going to hear about it. So I'm really excited. We had a great team that's working on this energy track app. In the middle is our 6K inverter. On the left is that outdoor rated 4.98 battery that Nathan had mentioned earlier. We can still leverage those indoor rated batteries, the one I showed you a little bit earlier, in our Boss cabinets. And these Boss cabinets can either hold 12 or 6 batteries, and they're outdoor rated, so you can go ahead and put them outside. Inside, they have terminal blocks, which make wiring them up pretty easy. And you can then kind of have one home run going out to the inverter. Access system, I think, is another great way to kind of have it all in one. You're not seeing, it almost makes it look like those marketing photos where you could really limit the number of conduits that you got running around on the outside of the house. This one, it can incorporate either a solar arc. In this example here, we have our inverter. And then on the bottom, you can have anywhere from 4 to 6 batteries. And these batteries, the ones you're seeing here are our amplified 3.8 kilowatt hour batteries. They're all being paralleled together using our bus bars. And then you can see the terminal blocks that are then combining those two sets of three to have one complete home run. And these ones do hold our UL 9540, a 9540 certificate that was informed by the 9540A safety testing. So we're going to get into the meat of the topic here. Essentially, we're going to talk about how it's important to charge our batteries and discharge our batteries and understand the limitations. We're going to talk a little bit about C rate. So the C rate is the rate at which you can continuously charge or discharge a battery relative to its capacity. So our batteries are rated at C/2, which means that you could discharge them or charge them completely in 2 hours. For example, with our 3.8 kilowatt hour battery at 75 amp hours, you could charge it at half of that, 32.5 amps at 48 volts. You could, and if you wanted to think about it in watts, right, 3,800 watt hours, divide that by 2, you'd be able to charge one single battery at 1,900 watts continuously. And of course, as you add batteries to the bank, that rate doubles or increases incrementally with each battery you add. One thing we really want to understand, and this is probably the last thing on anybody's mind right now with the summer we've been having, is that as you're charging batteries in cold environments, it's important to slow down that charge rate. And with our amplified batteries and with our simplified batteries, they have built-in 10K thermistors that can tell the piece of equipment exactly what the temperature is and what the appropriate charge rate is for that battery so you don't damage it. Maybe a lot slower, maybe C/20 or even less. And as you start to slowly charge up that battery, you start to build there's internal resistance in that battery, and you can start to build up heat, which can then allow you to incrementally increase that charge rate. Storage concerns, a lot of people have these winter cabins and one of the or summer cabins that they leave empty in the winter, I should say. And I get this question a lot, can I just go up there and shut everything down? Yes, you absolutely can. Our batteries use about 1% state of charge per month. So the idea that you can leave a battery unattended and then come back in spring and make sure you get a good charge on that battery is the first time around. But absolutely, you can leave a battery sitting there. You can see the temperature considerations when we're having that battery sitting there idle. And you want to be sure that we keep that, a lot of times you're not going to be at that extreme. And it's important to understand too, the difference or the gradient between the internal temperature of a battery and what you might experience in an ambient temperature. For example, in that picture there, you're seeing at the bottom, I would imagine it's a lot warmer inside that building than it is on the outside there. A lot of times other components like the inverter or charge controllers are also generating heat, which can help keep the batteries warm. We have other talks that really go in depth more on these cold weather considerations. What you're seeing here are heating pads that can be added to some of our batteries. We do need to, ahead of time, let us know that. So in the factory, we can add the appropriate hardware to leverage these heating pads here. And also,
Daniel,
go ahead.
I'm just going to interrupt and remind everybody. So these heating pads are great options if you're trying to be able to charge your batteries up early in a cold morning when that sun is available. You want to make the most use of your sun hours. And these units are available with both of our Phi batteries and our Amplify batteries. We can wire this. It gets wired directly into the BMS. It runs I believe it's a 150 watt heater in that heating pad, and it can warm those batteries up so that they're ready to go. It uses internal temperature sensing to regulate those heating pads.
Yeah, and I think so that's the rate, and you would understand that they cycle on and off, and the energy consumption over time, over a day, over a year, would be dependent upon what the the delta between the outside temperature and the inside temperature of the batteries.
Point, yes.
Yeah, Victron makes some great other third-party devices that can help reduce charge rates as well. Insulation, of course, can help trap that heat that's generated by those other components like the inverter, like the charge controller inside a cabinet, and retain whatever heat. A lot of times we want to put insulation underneath the batteries so that the batteries aren't touching a cold metal shelf. and where we could lose heat through conduction. So as we're mentioning earlier, the communicating batteries, when leveraging the communication capabilities available in certain inverters, like a solar, like our inverter, the battery can actually tell the inverter what its internal temperature is and then adjust its charging rate accordingly. That's why you're seeing this chart here. If you are going to be using our batteries in the cold weather environment, consider using our Amplify batteries. You can discharge a battery pretty cold, pretty warm, but when you're charging the battery is when we have to be a little more careful. And that's why you can see the Amplify battery, when it gets down to -4, -20, it's going to tell that inverter, hey, charge me at 1 amp and continue charging me at 1 amp till my internal resistance creates some heat in that battery, which then allows me to continually ramp up that charge rate. So you can see that the charge here, once it gets too cold, it's just going to stop altogether below 20 degrees C. But you can see as that chart, as temperature is slightly warm, we can increase that charge limit, and you can see the cutoff. So keep in mind that these there's multiple thermistors, and Nathan, correct me if I'm wrong. I think we have a BMS thermistor, and we also have thermistors that are embedded in the cell packs as well.
Sorry, Daniel, I was muted, but that is correct. We have a number of thermistors inside the communicating batteries packs to monitor temperature at different locations. So great point. And you do want to point out that this has to be done with a appropriate communicating inverter, but that offers us this solution to be able to charge in cold environments, as Daniel mentioned.
Thank you, Nathan. We have our simplify or the Phi 3.8. The Phi 3.8 is our non-communicating battery, and it comes in either 24 or 48 volts. And it's not that the non-communicating battery is anything less than the communicating battery. There's plenty of opportunities where you have maybe an old inverter or an old charge controller that can't utilize communications. So why bother buying a communicating capable battery that's more expensive when you could still utilize the standard Phi battery and maybe possibly leverage some Victron equipment for those cold weather applications. And then the Amplify battery only comes in 48 volts. And kind of what I want to point out here is that the C/2 discharge rate is pretty quick compared to what I'm used to with the lead acid days, right? With lead acid batteries, a C/20 was probably called out, or C/10. And as you increase that discharge rate of a lead acid battery, the rated capacity of that battery also decreases. So we've rated our capacity of our battery based on that C/2 discharge rate. And you can see the 75 amps for a 24 volt battery is the same amount of watts as 37.5 amps on that 48 volt battery. So the C/2 discharge rate, you're still getting the same number of watts out of that battery, whether it's the 48 or a 24 volt version.
That's a great point, Daniel. This talk is focused on these Phi and Amplify batteries. We also have an outdoor rated waterproof battery that Daniel showed you all earlier that also has that advanced BMS to offer cold temperature charging, high temperature curtailment. It's communicating as well. And you've seen that battery in some of our other slides. So I do want to mention that one. If you are doing an outdoor install, or if you want to do a wall mount, that battery comes with the ability to just hang it on a wall as opposed to needing racking.
Yep. Thank you, Nathan. So how do we charge a battery, right? So when we first start the bulk cycle, what we do is we have a constant current where we're holding the current at a constant set point. And usually what we do is we program the inverter, or we program the charge controllers so that if we look at the C/2 discharge rate and we figure out how many batteries we have in the bank, we can then usually a lot of times the amount of amps that a battery bank can handle usually exceeds the amount of amps being able to be provided by a single piece of equipment. But a lot of times when I see, say, a larger inverter with just 2 batteries or 3 batteries, a lot of times you have to adjust that current so that you're not exceeding that C/2 discharge rate. So what we're doing is we're pushing current at a constant current, and where the voltage is slowly ramping up. Once we reach a certain voltage set point, usually around 56 volts, what we then go into is a constant voltage, an absorb cycle. And what we do is we hold the voltage at a certain set point, and then either we start a timer and we push current for a certain amount of time, or if that's not available, a lot of other systems will monitor how much current is being accepted by that battery bank. And as soon as it is reduced to a certain level, 2% of the battery bank's capacity, we will then start a float charge. And then the float charge will kind of just keep the batteries topped off. A lot of times we don't want to float the batteries with a generator, right? Because there's no real need to. We'll rather go through those cycles. We usually don't float the batteries with grid either. What we will want to do, though, is float batteries from solar. If we have, say, for example, an off-grid system and the solar's kicking and it's providing enough power to provide the loads, we're going to just keep those batteries floating. In grid-tied situations, it's a little more dynamic. A lot of times we can tell the inverter what priority we want that energy to float to, whether we want to send it back to grid, whether we want to support loads first, or whether we want to charge the batteries first. So as it used to be, just let's get a charge controller and charge a battery. But now with these more dynamic systems, we can really tell the system where we want energy to go first and in what priority. With those old charge controllers, and we won't get too deep, but there are PWM charge controllers, and there's also MPPT tracking charge controllers. But really what you want to look at is, does the manufacturer warranty that charge controller to work with lithium-ion batteries? Can you adjust the set points in that charge controller to treat our batteries correctly? For example, the 56 volts disabling the equalize. A lot of them have the ability to have adjustable set points, but maybe the set points aren't in the range that need to be set appropriately for our batteries. And can you adjust that absorb time accordingly? Sometimes our batteries, if they're discharged beyond what they were, you didn't program the inverter right, and the batteries are discharged below their threshold, and the battery goes into a self-protect mode. That battery management system has the ability to protect itself, and it's going to disconnect itself from a situation that it doesn't like. Sometimes what that means is that you have to get an external charger to kind of jumpstart that battery to get that system to come back on. And there's a couple of our recommended battery chargers or power supplies that we like. And if that does happen to you, call tech support. We're here for you. We're going to pick up the phone, we're going to open a ticket for you, and we're going to walk you through everything you need to know on how to do something like that. It's pretty rare. And if you sized your system properly and program your system properly, you should never have that occurring. Really, that battery management system is the last line of defense, kind of the lifeguard of the system. So we talked about discharging. Let's talk about discharging the batteries. We still hold that same charge rate, that C/2 discharge rate. But what's important to understand is that we can have a surge capability with discharging, 80 amps for 10 minutes, and the Amplify battery can do 100 amps at 10 minutes. And this I will note, though, that if you're looking here, we have a slightly higher discharge rate on the Amplify battery. All of the batteries do have 100 amp breakers, but we are calling out 80 amp surge on the 48 volt battery as well. And keep in mind, 24 times 80 is not the same as 48 times 80 on that surge. So if you are looking for starting more loads, inductive loads, motors, consider leveraging the 48 volt Phi or Amplify battery, because we're able to provide that kind of a little bit more oomph to get systems started. And again, the limitation may be your inverter, not necessarily the batteries. And you're going to want to program your inverter properly so that you're not exceeding these rates. Let's talk about state of charge, and then I might have Nathan talk us through this illustration here on the right. If you were to look at, and we're going to look at some graphs of the state of charge of a lithium-ion battery, A lot of times back in our good old lead acid battery days, we could use the voltage of the battery to give us a good indication of what the state of charge of the battery is. With lithium ion batteries, the graph is a lot flatter. So you kind of have knees at either end. But what this means essentially is that a very small voltage difference can represent a very large difference in state of charge. So very small, like 1 volt, can mean the difference between a 20% state of charge battery or a 70% state of charge. So what's important is that we're not just utilizing voltage to determine the state of the battery, but we're using shunts, right? We're measuring amps in and we're measuring amps out during discharge and charge cycles to then transmit a very accurate state of charge to a piece of equipment to the app, so that the homeowner sees an app and they have a very, or you, the installer, has a very good understanding of what the state of charge is. We're going to talk about this here in a minute, but under charging conditions, the voltage of the battery isn't necessarily going to be the same as it would be at a resting state. Alternatively, under load, the voltage of the battery is going to be less than the resting voltage, although they still may have the same state of charge. And also temperature plays a little bit of different. Nathan, did you want to walk us through the figure on the right?
I'd be happy to, Daniel. I want to point out that a typical battery has what we'll call a resting voltage curve, and Daniel's going to show that curve, and that curve depends on the state of charge. So as we increase the amount of charge that's kind of moved over into the anode side of the battery, which represents a charged battery, the more charge on the anode side, the voltage of the battery increases. And as Daniel mentioned, especially with lead acid batteries, it's a very distinct curve where, you know, that voltage can pretty accurately tell you what the state of charge of the battery is. We can do the same thing for a resting lithium battery, but the curve is much flatter. We don't have as much of a slope to the curve. And so it's a little bit harder to tell, especially in that 20% to 90% state of charge range, exactly what the state of charge is of the battery by its voltage. So as Daniel mentioned, if we have a battery in a charging cycle, we are having to apply to the battery bus bars, right? We are having to apply a higher voltage to push that charge into the battery. And in a charging cycle, that means that the internal resistance of the battery causes a voltage above the resting voltage. Because current is being pushed through the battery, right? And that internal resistance was what is causing that voltage rise above the resting voltage. It's current dependent. So if I charge the battery twice as fast, I expect to be twice as much above my resting voltage curve. There's going to be a similar curve for discharge, and it would be below the resting voltage curve. And so I think Daniel's next slides are going to indicate to us a resting voltage curve. So we look at this resting voltage curve and we can see a fully charged battery. It depends a little bit on temperature and it depends a little bit on age of the battery, etc. But will typically sit above 53 volts, right? So a fully charged battery will be somewhere between 53 and 54 volts. Now it rises very quickly between that 98% state of charge and that 100% state of charge. So we're not even showing it on this curve. It's also almost asymptotic there, where it could go up to like 55, 56 for a 100% state of charge battery. As you can see, as the battery is depleted by discharging, the voltage drops. It drops all the way down to about 50.2 volts. So it's not a major drop. It's about a 3-volt drop over a 90% state of charge drop. In that last 10%, it drops off very quickly. We call that the knee of the curve because you're dropping by a couple of volts, even more than a couple of volts, in that last 10% state of charge. So we recommend to customers not to always discharge to zero. You get a lot less cycle life out of the batteries if you discharge to zero. If you're discharging to 20%, we're expecting 10,000 cycles out of this battery. Now we know that it's not always going to be discharged to the same amount, but just to give you an idea, we're expecting 10,000 cycles if we discharge to 20%. That would be 27 years if cycled daily. We're expecting 5,000 cycles if discharged to 10%. And we're expecting 3,000 to 4,000 cycles if discharged 100% every time. So that being said, let's look at the next curve where we can actually look at a discharge. So we're still in the discharge state here. We're looking at a discharging battery. Notice that those voltages are below 53 volts right from the get-go. So as soon as we start discharging a battery, the current's going the other way. So the voltage of the battery would be below that resting voltage curve. So we're not showing the resting voltage curve here, but as Daniel is indicating, it would be above the darkest green line there.
Yeah, and just a quick note for everyone,
Yep.
Nathan, is that this is showing, the previous one was state of charge, where this is depth of discharge. So 0% would indicate a fully charged battery.
Good point, thank you. I am remiss in not saying that too. So thank you, good point. And so as we are discharging quicker, right? So from left to right is a discharge cycle here. As we are discharging more quickly, the higher the C/2 rate is the fastest that we are showing a discharge here. The voltage is below. And so just keep that in mind. If your battery is in a discharge cycle, using the voltage to try to determine state of charge is a little bit more difficult than if it's just in a resting cycle. And the faster you're discharging, the more that curve is shifted downward.
Additionally, temperature matters.
Yes, additionally, temperature matters, right? So it looks like the words there got cut off, but what I am showing you here is actually that it's supposed to say resting voltage there on that top curve. We had a little bit of a problem. We transferred from PowerPoint to Google Slides recently, and it looks like I didn't catch that. But that's a resting voltage curve there, and I'm showing you different discharge cycles, all at C/2, right? So all at that C/2 would mean it would discharge the whole cell in 2 hours. And what I'm showing you here is at really cold temperatures, you'll see a significant difference, right? So you're looking at Fahrenheit temperatures as well as Celsius temperatures there. And when we get into cold winter months, you'll see a bigger drop when your batteries are first starting to discharge. So you're looking at discharge profiles here at low temperatures that one of my students at the university collected in the lab. So these are not simplified cells, just cells that we had bought that are LFP. Just pointing out to you, you will not stay at a particular temperature. As a battery discharges, it generates waste heat, and that heat actually can be used to heat up the battery. And you'll end up, if you start discharging a battery at a low temperature, eventually having that temperature of that battery rise to 20, 30 degrees, and we'll be able to get most out of this battery. The point here is to let you know that at cold temperatures, there's increased internal resistance due to a lack of mobility of the electrolyte. So the lithium has more trouble moving through a much more viscous electrolyte at cold temperatures. And so this effect of shift of the curve during a discharge cycle is more pronounced at cold temperatures. Okay, so hopefully we didn't go into too much depth here. I see 4 or 5 questions here in Q&A, so I'm going to have a look at them, and we'll see if there's ones that I have to interrupt. So
okay, yep, I do. To be respectful of everyone's time, we have about 12 minutes left, and so we'll keep going.
Okay, thank you. Sure.
Yep, and I kind of mentioned this earlier. We want to be sure that we don't exceed the continuous charge or discharge rating of our batteries. And one way we do that is by sizing the system correctly. In this example, we have one of our 6 kilowatt inverters, and the continuous output of our batteries is 37.5 amps for that 48 volt battery you see. So we can, get around almost 2 kilowatts out of this thing, 1.9 kilowatts, 1900 watts. But what we noticed is that the continuous discharge from that bank is a little bit less than what that inverter could possibly pull. So one of the ways to do that is you program the inverter to not discharge that quickly. Another way we could do this is adding a breaker. And if you are going to add a DC breaker to prevent this, it's important to get the right one. A lot of these breakers have a trip curve that you can see here, and kind of what we're showing here is that they don't trip exactly at 100%, right? They actually trip at they can trip at slightly different, potentially even above 100%. So that it's possible that if you use a breaker like the one on the right, that you could be in a little working area that is above 100%, but never trips. And so it's important that if you are going to leverage breakers in the system, that you get the appropriate one. When you're DC coupling them, really quickly, we're going to point this out, that we're landing the DC bus, right? We always want to run our batteries in parallel, and we want to use conductors of the same gauge and the same length to go to a common connection point, and then feed back up to an inverter. So let's take a look at some system layouts here. What we have here is, you come out to a house, you don't necessarily have to do batteries. Our inverter has a great price point where you can come out, sell the homeowner DC coupled solar, sell them an inverter, and tell them that the system's battery ready. We can always come out and add batteries to the system. You can really quickly, easily upgrade this system. We got a meter main on the right. We can backfeed solar back to we'll land our backfeed breaker on the bottom of that panel. So we're going to feed any loads and then send anything back out onto the grid. We can always add a battery in the future. In this example, we're showing a Boss 6 battery cabinet. And this really is going to provide that homeowner the, are you ready to go? And we can add this battery system later, and they can still leverage that 30% tax credit. Battery backup. So the idea that maybe the homeowner doesn't want solar, doesn't have solar, doesn't need, doesn't want to have it. We can still add essentially it's a whole home UPS system, right? And one of the things to understand or explain to homeowners is that there's no way to recharge those batteries in an off-grid situation unless you have a generator to potentially recharge it. And utilizing a 2-wire AGS signal to start, the inverter knows when the batteries get to a certain level, we can start that generator, run the generator, charge those batteries up, and then shut it down. Of course, we could also add solar to the system to augment the generator. So you could create a very robust microgrid for somebody's home where they can potentially go indefinitely if they're able to manage their loads correctly. Coupling in an ESS system. In this one example, we're showing some of our outdoor rated 4.98 batteries, again, DC coupled. We're getting larger systems now. In this example, we're utilizing a midnight solar combiner to bring in 2 battery banks. And then we're able to come off of that midnight solar combiner and branch out to our 3 inverters. We could be backfeeding the grid still, and we could also be running our critical loads backed up subpanel as well. Really, a solar could also be utilized. We've had a long history with working with Solarc, and everybody loves the 15K Solarc. Why? Because it has a 200 amp pass through with a 200 amp rated main disconnect or service rated disconnect. So we can have a meter can, pass it right through, get up to our loads, and then in the event of a grid outage, that Solarc 15K can isolate itself from that meter can. We can use energy stored in those batteries to power homes loads. We can charge it with our solar, and we can use a generator to start it. One thing I forgot to mention on those previous slides is that internal to our Simplify inverter, we have a built-in APS smart transmitter. So code now requires that we have rapid shutdown capabilities on the roof. You can use AP Smart System modules up on the solar panels, and then you don't need a separate transmitter because that's already built into our inverter. In this example, the solar, we're showing the Tigo. So the transmitter is that little green guy right there in the middle that's imparting a keep alive signal out onto the rapid shutdown modules. In this case, some TS4Fs of DC coupled solar. Off-grid, absolutely we can do off-grid. And it's something that's unique to us. Enphase isn't going to let you go off-grid. Generac's not going to let you go off-grid. So we warranty off-grid systems. And that's really, we've had a lot of the industry got started in the off-grid, with the kind of the people up in the hills. So it's exciting to see some of those systems. In this example, we're still leveraging one of our generators. That's a PP12, a Power Protect 12. It's a gaseous generator, so either propane or natural gas can power that generator.
So Daniel,
yes.
Quick question. You mentioned that we can do off-grid with these systems. Can we do that with our Solarcs as well?
Solarcs absolutely can do off-grid as well. And you've seen a lot of off-grid systems with Solarcs.
I have a trivia question. We've got about 6 minutes left, and Kenny asked a great question. It's in the Q&A. He asks a question about what was his original state of charge before charging his system, and he provides some information here. He has 2 5 batteries, right? And he's charging at 22 amps. He does this for 5 hours. He then charges in an absorb cycle at 2 amps for just 6 minutes. So he's got 150 amp hours and 2 5 batteries. He charged for 5 hours at 22 amps. Okay, so he's added 110 amp hours to a system that has a total of 150 amp hours. So everybody, what was his approximate state of charge when he began? So there's a good question. I thought Kenny asked it. It's in the chat. I've got an answer for you. Daniel can probably give an answer off the top of his head, but I think can they give answers in the Q&A? I think they can.
Yeah.
And how about this? We send a sweatshirt hoodie to the first person who gets the right answer here. So go ahead and submit your answers to Kenny's question in there in the Q&A, and we'll send out some swag for the first right answer there. Yeah.
And while people are coming up with those answers, I'll finish off to 5 minutes here, and then at the end we'll figure out the winner. Communications is important. We want to be able to have each of the batteries communicate its state of charge up to the inverter. There is network terminators that's going to be involved in there, and just understand that the communications are only going to be able to be, the batteries can always send out information. You just have to make sure that you have a piece of equipment that can listen and take those commands and act with them appropriately. Furthermore, that if you do have a piece of equipment that can listen to the batteries can auto-populate certain set points in the inverter. So it saves you a little bit of time commissioning the system. Please always go out to the truck and get your torque wrench. Don't let one of the installers get an impact driver and go to town on some of these battery lugs. 160 inch-pounds is what we're looking for. Ideally, you have one of those nice insulated torque wrench there. This is Nathan's house. And again, what a beautiful install, Nathan. What we're seeing here is the kind of the screen off of our app showing, where things are going. In this example, he doesn't have a generator, which is why you see that kind of grayed out down on the bottom left. But again, talking about treating the batteries right when referring to charge and discharge settings, you can see that you can alter those current values so that you're not overcharging the batteries too quickly or over discharging the batteries too quickly. These apps are very powerful nowadays, and you can adjust the operating profiles and you can really see the individual battery levels, which is understanding that state of charge. A lot of times homeowners and maybe some installers read too much into these. So, don't go crazy. Oh, one says 61, one says 60. I'm calling my installer tomorrow. I have no idea. Some of this is normal, and just understand what can be normal. Series versus parallel. That's some good old lead acid batteries all in series. We want to run our batteries in parallel. And you can see we're utilizing a Midnight Solar combiner. I think this one has the breaker built into it in that example on the right. Further, if you're going to run them in parallel, don't daisy chain, right? You can see in this example that these two batteries are kind of daisy chained and then coming down to a common connection point. What we'd rather see is conductors all going individually to each battery to a common connection point. I love this. This is a great install. Some Outback, and then we have a Midnight Solar combiner in the middle and a bunch of our older. The reason I'm calling them older is that these are the ABS plastic black batteries, where the newer batteries are powder-coated metal cases. Oh, wrong button there.
Daniel, we had I think an important question come in. Not to interrupt these photos because it's always fun to look at them, but we had somebody ask if our inverter acts as an automatic transfer switch.
Yes, absolutely.
Yep, it can control the switching, and we've had customers that are doing designs in which they actually eliminate and sell their transfer switches because they can now use the inverter to act as a transfer switch.
Yeah.
Keep in mind, our generator input is limited to 40 amps per inverter. So if you parallel a couple of our inverters, you get 40 amps. On the Solar 15K, Daniel, I think you might have this in your head. It's 80 amp input on the generator port for a 15K.
I believe so. Yeah, and I'd have to double check that to be
I think
certain.
it's 80 amps, and they get a 200 amp pass through, so that you get a big pass through on that Solar. It's a little advantage of the Solar over ours, but there are some advantages, as Daniel pointed out, on ours. Just a quick word back to the trivia, and then I turn it back over to you, Daniel. Sorry for co-opting
No, it's
here.
all right. Let's hear it.
So a couple of people. So Drew got this correct. He said at 30%. That's pretty close to what I was estimating. And Robert actually did it even more carefully and got 26.7% state of charge beginning. And both of those answers are good. So Drew and Robert, and we're going to have you email us your addresses. I'll put our email address there. It's training@simplifiedpower.com, and we'll send out some sweatshirts your way. So thank you for answering. Daniel, all you.
Yeah, maybe we should send some hats out, considering the heat. Example. That's great. Thank you, Nathan. In this example, I just want to make sure people understand, if you are going to be leveraging our bus bars, that we do that in such a way that you can see the bus bar here as a positive and a bus bar here as our negative. And so this battery is going to end up kind of working harder than the next. What we want to do is we're going to tap off our positive on one side and our negative on the opposite. That way, these three batteries together contribute rather than just one battery. And you can see some of our newer style, the bus bars that are designed for two batteries, they kind of tap off in the middle. So you're maintaining that capability. You can use terminal blocks. You can also use combiners. This is another example of using terminal blocks. The reason I wanted to point out this is that this is an insulated battery cabinet, so it gives you an idea of some cold weather mitigation strategies. This is what it can look like to replace lead acid batteries with nice lithium ion. Sorry, I'm going fast, everyone. I want to be respectful for everybody's time. Another example of how you could rip out lead acid batteries or flooded batteries or even sealed lead acid batteries and pop in some lithium ions. These batteries are going to provide just as much power, if not more, and just as much energy capacity as well, because we're able to drain them down. Mobile systems, there's a lot of great installs on mobile systems, and we talk a little bit about that in environmental considerations. Be sure you program these systems correctly and use some shock absorption, padding, so that the batteries are a little isolated from vibration. Custom bus bars are definitely available. Storm power components make some of that stuff. Victron has always been great. Their Lynx Power In is an example here of us paralleling up some products. The battery cabinets, the picture on the left looks like an old school off-grid kind of system with some, trace and some outback systems. That picture on the right is much cleaner. Both examples are using battery cabinets. We're at the end. If anybody is out there looking to be part of our Elite IQ installer program, please scan that QR code you see there on the screen. Email us. There's opportunities for us to put you on the map, drive business your way. You get a newsletter, and there's also a little bit of opportunities to get rebates on some of your battery installs. If you're here for NABCEP credits, training@simplifiedpower.com. Email training@simplifiedpower.com. Be sure to include your full name, first and last, so we know how to spell your name correctly on the certificates, and we'll go ahead and send you the 1 hour certificate of completion. Nathan, any questions?
Good question came in and asked about, we were mentioning the possibility of using the inverter as a transfer switch. And one of the questions came in, is our inverter rated as a service entrance rated transfer switch? And then I'll follow that up, Daniel, with a second question, is the Solar?
So not all Solarks are, and our inverter is not. I think it's particular to the 15K that has that feature. And I will tell you this, that it's not a true transfer switch. A transfer switch are more in the generator, like make, break before make, and that's why in a lot of transfer switches you have to reset all of your clocks. and your internet goes down and reboots. And a lot of these inverters, they're micro interconnection devices where the transfer time is so quick, like 8 milliseconds on ours inverter, that a lot of times you're not even going to see the lights flicker. You're not going to have to reset your clocks, but they're treated a little bit differently in the code.
Okay, so good answer, Daniel. Right, the Solark 15K is the only one of our lineup currently that is service entrance rated, and I believe Solark is coming out with 30K and 60Ks that we have battery pairs for. But I don't know. I think they're service entrance rated, but again, those are going to be high voltage units, and I don't have more information for you on those right now. But Daniel said it. The Solark 15K is service entrance rated. Our inverter is not, but it's not a true transfer switch. It's an 80 amp pass through, and the Solark 15K is really operating more like a UPS than a transfer switch. So good questions. Diane asks, how do our batteries compare to Tesla Powerwalls? People love the Tesla name, and it would be nice to know how to compare and sell over them. Thanks.
Well, I think a lot of people like the Briggs & Stratton name too. And that's a lot of people who want Tesla Powerwalls don't even know why. They just like the name and that's what they want. And so by using Briggs & Stratton, that household name allows us to leverage a household name that builds confidence in the homeowners. We don't want to go too deep, but Tesla leverages a cobalt chemistry. It has
NMC chemistry, yes.
Yeah, yep, NMC chemistry, and has active cooling systems in the batteries.
It's also rated for an expected shorter lifetime than ours, and we're offering a longer warranty than them with unlimited cycles. They have a throughput cycle limit on their warranty. So I also want to point out that, I want to point out that, Tesla came out with their Powerwall in April 2015. How long have we been around, Daniel, making our batteries?
Yeah, a lot longer. And that's, it's really, we're kind of at the beginning, everyone. Really, this is just the beginning of this distributed home energy assets. And so I'm really excited to be part of this industry. I'm really excited that everyone's here to learn, because whether we do this system or that system, we're all contributing to the solutions here, and being part of the solution, not part of the problem.
And I agree with that. And we don't want to bash Tesla Powerwalls. We think they're great, and they're generating more interest in this industry as well. We just think that we have a longer lived battery than theirs. And we think we have a simpler solution, which is our ESS system. So good question, Diane.
Yeah.
I'm looking through Daniel here. There are a couple people pointing out some of the bus bars where the cables are not attached correctly. Kenny asks, it's a grid isolation switch. Yes, in reference to our earlier communication about transfer switch versus grid isolation switch. Depends, Kenny. The answer is yes, but in an AC coupling situation, when you are using generator, it's not necessarily an isolation switch.
Yeah, at the end of the day, what we don't want to be doing is the power's down in the neighborhood, and here you are backfeeding the grid, and you're going to electrocute the linemen down the road. So isolating the islanding, anti-islanding is really the key there. And the hardware is there to make that safe for everybody.
Okay, I think that we're probably going to have to call it there. We are over by 7 minutes, Daniel, and I love these questions, and we will continue to answer them by email. So feel free to reach us at training@simplifypower.com. I guess there's one last question I'm going to let you take, Daniel, from Scott as we wrap up here. To follow up with your question back to me, as the speaker mentioned, California is not running new natural gas lines to some developments. So earlier, this person was asking, Scott was asking, was saying it sounds like California is doing away with natural gas. What are the options for keeping a generator running? He says, as time goes by, water heaters will also eliminate natural gas. So what is Briggs & Stratton's path forward for generators if natural gas is de-emphasized? Propane is not desirable. So is Briggs & Stratton generator line a dead end? What do you think, Daniel?
I don't think so. there's always opportunity. These are new developments, which is going to be kind of I could see 200 years down the road, maybe. You know, but in the meantime, there's a lot of opportunities to still leverage gaseous fuel generators. And there's a lot of existing gas lines already out there. You're gonna have to,
Daniel, what can batteries do for a generator?
they can help reduce runtime on the generator. They can help reduce maintenance, extend the warranty of those generators. I think really what it's going to come down to is you're going to have to bury a propane tank in the backyard and do that, so you don't have an unsightly propane tank. But for people, you know, and we all have customers out there that are really looking for that ultra resiliency, right? That want to have the ability to have a microgrid on their home. In order to do that in a lot of situations during the winter, you're just not going to have the solar production that's available to run those loads. So leveraging a generator in these energy storage systems, especially people that are looking for very robust, resilient systems, is going to be key. And there is going to be, I think, a long runway for opportunity to do that. Next week, I'm actually talking to that specific topic on how to combine generators and energy storage systems, and why they can complement each other, why there's still going to be a solution for a long time to come.
How do people register for that training?
Go to simplifiedpower.com, check out our training calendar, and you can register there.
Thank you, everybody.
Thank you, everyone.